Hey guys, JP here from JP's Underdog Guitar Repair. Just wanted to follow up on the Andrew White guitar, and in all fairness, I did say this was going to kind of be a piecemeal type job, so I do apologize if there's been a bit of a wait for. I believe we're on episode 3 already of this guitar repair. You can see the guitar in the background there. So progress. Let's just start with that. I'm glad to report that the repair on the top went really well. I did decide on basically CA glue or super glue. It turned out to be a very good decision, and the reason for that is that the glue actually penetrated all the way through the soundboard and actually into the brace that was had just a hairline crack in it. Penetration was 100% on that, and I'm glad to report that it's 100% solid now, which is fantastic. Even in the spots where the cleats were placed, I could see some of the CA glue actually seep out underneath those, which means that that's a better bond now as well, which is great. So it shored up pretty much everything, including there used to be basically a crack in the lacquer, and the lacquer on this guitar is fairly thick, so you can see that line. If you're looking at it, you can see basically that flash on the top. That's gone, essentially. So I'm grateful for that. That went really, really well. The top is repaired and we're good to go forward. So next comes the bridge, right guys? So let's have a look at that. So I wanted to call this video The Tale of the Two Bridges, and there's two reasons for that, because there's two bridges. I know it's amazing. It's actually hard to watch. I apologize. But I made two bridges for this guitar. So I want to first start by saying this guy here, the original bridge that Andrew White actually spec'd out for this guitar, is 6.5 inches. Okay? And that's not unusual for a classical guitar. I mean, you can get a 7-inch classical guitar bridge on Amazon. If you want to order it there, it's available. It's a thing. You can get StuMac, Amazon, LMI, anywhere. So that's a normal thing. It's not normal for a standard steel string guitar. To be honest with you, 6 inches is 6.25 if you're lucky, maybe what you're going to get from them if you're going to order a pre-made bridge. So looking at that and looking at the wait times on blanks, to make a bridge for this guitar just seemed like too much of a wait. So essentially I made my own bridges. So that's why we have Tale of the Two Bridges. I made two bridges. Let's have a look at those right now. So first bridge, beautiful ebony bridge. No, it's actually hard maple. Okay. And you might say, wait a minute, you can't make a bridge out of maple. You can easily make a bridge out of maple. And yes, it's not an exotic wood. It's not rosewood. It's not cocobolo like the original bridge. And to be honest with you, the fact that the original bridge was cocobolo was part of the problem. It turns out that the cocobolo is actually a very waxy wood, and it just, if it gets hot, it releases wax, and it's like trying to glue anything to wax or wax paper. It's just not going to adhere. So I honestly, in my opinion at this point, don't think that cocobolo is a smart choice necessarily. To be clear as well, this bridge was epoxied on originally, which is far from ideal. Most places will use hot hide glue or any type of aliphatic glue, so that if there's ever an issue, it can be heated up and removed without causing any issues, right? That wasn't the case here. Not only was it epoxy, but I as you can see, the coverage wasn't very good, right? So they put the epoxy down, it probably sat for a little bit too long, then they stuck the bridge on, and Bob's your uncle, sent it out the door. And that's unfortunate, but that's seems like that's what happened. Still not slamming the builder. Everything else is really great with the guitar, and we live in a modern world where stuff happens. So, again, I'm not picking on anybody. I still think it's a great guitar, and I can't wait to get it restrung and all that stuff done. So, I opted to make a new bridge, like I said. So I said the first time I made this. This is stained with basically a water-based glue, right? Glue. Wow. Water-based stain to basically make it black so it doesn't look like this, right? So originally I asked myself, well, what's the reason? Like, hard maple is a very dense wood. It's not horrible tonally. Why isn't it used in bridges? And after doing some experimentation, I think I know the reason. And the reason, in my view, is that it's just the amount of prep work required to make it user friendly, right? If I were to leave that untreated, not only would it look bad and clash with everything else, it would darken over time and probably not look very good. So there's that, right? So then the extra step to stain the bridge, right? Water-based stain. It's just maybe an unnecessary step. So in lieu of that, I reached out to Miller's Woodworking on Crawford, and instead of ordering something on Amazon that was going to take me, 3-4 weeks to get, especially when it comes to exotic woods, they supplied me with some walnut. Okay, walnut blank right here. Not terrible wood tonally. It's actually pretty decent. So I opted to make the bridge after making one out of maple. Maybe not the best use of time, but yeah, to make one out of walnut instead. All right. So went from this. That's a blank that I made, right, from the chunk that they sent me, which is kiln dried walnut, to this guy. All right. Not bad. Right. So there's a train of thought on that as well. I guess standard procedure, and there's two trains of thought on this. Standard procedure would be to go ahead and drill your pinholes first, drill your bridge pinholes, and then set the bridge, and then you can basically lay something underneath the strings, string it up, run all your strings through, and then hope to route this thing after the fact. Well, there's a few issues with that. First of which is, at that point you would have had a concave on the bridge. Okay. So in order to route that, and if you look at the bottom of the saddle, okay, there's no radius on that. It's completely flat. So in order to radius, or in order to route that slot perfectly flat, you pretty much have to start from a flat surface, route it with a template, which is what I did, and then move on from there. Make your contours, drill. At that point you would drill all your bridge pin holes and all that stuff, which is 3/16 if you're curious, which after the fact have to actually be chamfered in order to accommodate the bridge pins. Okay, so if you drill a 3/16 hole, what you end up with is this. Okay, you're going to get about that much penetration, which is perfect. And the reason it's perfect is that if you were to drill a bigger hole, and this whole thing would go in all the way, you're only getting contact around the outer diameter of the hole. Okay, so using a reamer, okay, which is what I'm going to do. I'm going to use a reamer, and then we're going to have that kind of taper. So the contact's going to be 100%. I also want to mention that when I drilled the holes, I took the initiative to set the pin on just a slight angle. We're talking a couple degrees, maybe 2 or 3 degrees. The reason for doing that is that when you string through, okay, when your strings come up, through, and back to the nut across the fretboard, eventually you're going to get a little bit of force forward, okay? This is kind of correcting that, and a bridge pin that's set on this slight axis, like I said, we're talking just a degree or two, is less likely to pull out, right? So I'm sure you've owned an electric guitar, and you put the strings in, especially on the E string, and you find that the bridge pin keeps popping back out. You can't, difficult to get tuned. That has to do with the bridge plate underneath the fretboard, or underneath the soundboard, sorry. And the bridge pins themselves, right? If you have a forward bias, they're going to want to lift up, right? So that's just kind of a careful consideration, right? I find bridge pins that lift up out of the guitar. It's an annoyance that's avoidable, and it's avoidable by setting a 1 or even 2 to 3 degrees max. Back set on the bridge pin, strings through, and then you're not getting that push. You're not getting, you know what I mean? You're counterbalancing that, which is great. So anyway, you have to challenge convention. If you have an issue with things the way they are, you have to challenge convention. That's one of those things. So at this point, I'm guessing tomorrow. I'm really hoping to set this bridge. I like the finish on it, and the finish is supposed to basically, I tried to get as close as I could to Cocobolo. Cocobolo has some black lines running through it, okay? Also, I want to put some relief cuts in here. Similar to this. This one doesn't really have an actual relief cut. That's just the strings biting into the bridge. I'll put a relief cut so that when the strings set across and onto the bridge, the break angle will be slightly increased, which will keep downward force on the saddle, which improves tone. Okay, so if you ever wonder, you're like, okay, well, hey, I shaved my saddle down, my guitar sounds kind of dull now. Why? Why is that? And it has everything to do with the downward force, the string across the saddle, downward force, basically transferring tone into the guitar itself, right? The less break angle, the less downward force, the less tone transfer into the actual acoustic guitar itself. Okay, and that's not rocket science. That's not just my postulation. That's just, I mean, it's just science, I guess. That's just the way things are. So anyway, my hope, and it again, it's Canada Day weekend, so it's going to be fairly busy. I'm guessing, but I'm hoping to finish this weekend. And as I do, and as I get it strung up and strum that first chord, you're going to be right there with me, I hope. And I hope to see you there. Appreciate all of you. Have a great Canada weekend, and we'll talk to you soon. Bye.